Hi gang, welcome back from your weekend. I hope it was a good one. If you remember on Friday, we had shortened periods and we were trying to get through derivatives of log functions maybe a little bit faster than what we should have. And so what I thought I'd do today is walk you through the rest of the examples from this note sheet. So hopefully you have your note sheet out. Let's just walk through a couple of these problems that we didn't have an opportunity to do. In this problem, it asks us to find g prime of x if g of x is equal to the natural log of this quantity. And so let's go ahead and see what we can do here. Hopefully you see the big picture. You see that there is a chain rule at play here. And so if we were to find g prime of x, what would that look like? Well, I see that this would be 1 over the quantity e to the x plus the ln of x. But then I need to make sure that I care for that inner function. As you can see, that would be the outer function that we've just taken the derivative of. Now, let's take the derivative of the inner function. And the derivative of that inner function would then be e to the x plus 1 over x. Okay, so let's see if we can simplify this. I'm going to go ahead and finish it here. This is g prime of x. We have e to the x plus 1 over x, all divided by e to the x plus the ln of x. And maybe you could do some simplifying there, but that is the basic final answer. And it would be easy enough to substitute a value in there to find the slope. Okay, let's see what you can do with this one on your own. F of x equal the fifth root of the ln of x. And I'd ask the substitute to just pause for just a minute or so until students finish this problem. And so hopefully you came up with an answer that looks something like this. And again, 1 over 5x to the ln of x to the 4/5. Feel free to keep it as a fractional exponent. That's perfectly fine. All right. If you turn your papers over to the back, let's take a look at some of the examples that are on the back of the notes. As you know, part of my job as a calculus teacher is to make your life as easy as possible. Isn't that right? And so, what I want to do is talk to you today about how you can simplify this process of using derivatives of logs by actually understanding and remembering some of the properties of logarithms. For example, we did one problem like this before we left on Friday, but let's see if we can just walk through a couple more together. Notice in this problem we're asked to find g prime of x, and so that looks like a problem we could handle with just calculus and calculus alone. But I hope you remember that you can rewrite this function as the difference of two logarithms. That is the ln of 2 minus x minus the ln of x plus 2. And I hope you see where we're going with this, because the derivative of this function that I've just written is far easier than the derivative of what we would have needed to do. If you look at this function, the original function, notice what we would have had to do if we didn't use properties of logarithms. Not only do we have derivative of a log function, we have a chain rule that we need to care for, and a quotient rule. And so I'd rather simplify that process by just knowing these properties of logarithms. So what's the derivative of the ln of 2 minus x? Well, we do have a chain rule there. We need to take care of this. 1 over 2 minus x And then notice the derivative of the inner, 2 minus x, is -1. So I'm just going to multiply that by -1, making the numerator negative. Then minus the ln of x plus 2, so that would be 1 over x plus 2. And then, of course, the derivative of the inner here, we don't have to worry too much about. That derivative would just be 1. Now, some might want to find common denominators here and try to simplify, but finding a common denominator here may be more cumbersome than just substituting a value in for x. And so if we can evaluate this derivative just this way, why don't we just leave it as it is? All right, so let's head down to the bottom here to another friendly function, and let's see if we can find his derivative. Well, I look at this and I see that I could find the derivative there, but there's a lot of strange things that could be happening. I see a derivative of a log function, I see chain rule, I see a product rule, and then I see 2 chain rules within that larger product rule. And so it could be a nightmare. And this could take a month of Sundays to figure out if we try to find the derivative that way. So maybe instead what we could do is separate this out and expand this logarithm a little bit first. Go ahead and see if you can do that on your own, and I'd ask the substitute again to pause, and then we'll see if you did it right. Alright, so let's see how you did. Hopefully yours looks something like this. Notice that the product becomes a sum of the logs, and also notice I used then the power rule of logarithms, not to be confused with the power rule of derivatives. And I brought the exponent out front to a place in front of the logarithm, both for the 5 and the 6. Okay, so now let's see if we can find the derivative of this guy. The derivative looks something like this. Everything I've done so far is pre-calculus. Now is when the calculus comes into play, and so let's find a rate of change. Or a derivative for this. H prime of x would be what? 5 times 1 over the quantity 2x plus 1. Now we need to reconcile the base. That's what I call it. And so multiply by the ln of 5. And then don't forget to take the derivative of what's inside. Derivative should be 2. Plus, same kind of thing over here, 6 times 1 all over that function, x to the 4th minus 3 times the ln of 5, and then multiply that by the derivative of x to the 4th. I've run out of room, so what I'm going to do is I'm just going to multiply it right away on top. 4x to the 3rd. Okay, now we might be able to simplify this just a little bit. H prime of x is the same as 10 all over the quantity 2x plus 1 times the ln of 5 plus, what do we have, 24x cubed all over x to the 4th minus 3 times the ln of 5. Alright, and so that would be our final answer. No need to simplify that. At this point, gang, it might be a good time to put up the homework problems from the Section 3.8 Practice Problems worksheet. There were 5 problems there. If we could get 5 people to put those up on the board and explain those to the rest of the class, that would be very helpful. The answer key is provided to the substitute, and so if you have any questions about whether you have the right answer or not, you could check that first. While those 5 people put problems up on the board, maybe the rest of you can be comparing answers on the review worksheet, the properties of logarithms that you reviewed from pre-calculus, and just see how you did with that. So everybody should have something to do here over the next 5 minutes or so. All right. One more video, but we'll wait till after we go over homework to talk about that last problem on the note sheet.